In this lab, we are going to learn about BJT transistors. You will need to build the circuit on the breadboard, and you will need to use a 2N2222 MTN transistor here. These three capacitors are 1 millifarad capacitors. R1 is 27, R2 is 27 kilo ohm, R2 is 15 kilo ohm, RC here is 2.2 kilo ohm, and RE is 1.2 kilo ohm. You need to build R1 because you cannot use the potentiometer here because you don't have access to ohmmeter here. You will build R1 and R2 and RE from the resistors that are available to you. So for example, R1 is built from a 20K resistor, a 6.8 K resistor, and 200 ohm resistors in series. Then R2, which is the 15K, is built of one 10K resistor in series with two 10K resistor in parallel. So two 10K resistors will give you 5K. In series with the 10K will give you 15 kilo. This one also is built of a 2K resistor. I'm sorry, the RE is built of a 1K resistor and 200 ohm resistors in series. RL is 2.2, as you have it here. RL is 2.2K, and our signal is 10K. Our signal is 10 kilo. One important thing here is that you need 9 volt DC. Again, your voltage supply from the analog discovery has a maximum of 5 and negative of -5, so you're going to use the red wire with +5 and red wire as +5 to connect it to here, this node here, and -4 to connect it to this node here. So you don't have a ground in your circuit, just the red wire goes here from the voltage supply 1, and the white wire goes to here with -4. The function generator needs to be, I will explain this later, but it needs to be a 50 millivolt peak to peak, which means 25 millivolt peak, 1 kilohertz sinusoid. Then you need to measure different values. For example, the things that you can see on board include VC, VE, and VB. These are the main things that you need to measure. You will not be able to measure IB, okay, because we are not in lab and we don't have access to multimeter. But you can measure IC and IE by dividing VC and VE over RC and IE. For example, IC is VC over RC, and IE is VE over RE. There is nothing else here to mention. Let's move to the circuit. You can see the 2N2222 BJT transistor. This notch here is the emitter. So the right pin is emitter, the middle one is base, and the left one is a collector. And you can see that it looks like this from um, the bottom. So the left one is the right one is the emitter, the middle one is base, and the left one is collector. So I'm going to put it back in my circuit. I have made my circuit in a way that this tree go like this, okay? You can see it, the notch is on the right and the base is the middle one and the left one is the collector. I use the green wire to bring the emitter node to somewhere in this distance from the BJT, and the white wire is for the base and the blue wire is for the collector. Then I have used so I will start from the emitter connections. As you can see in figure 1, you have RE and C3 connected to your emitter. RE is 1.2 and CE is C3 is 1 milli. So this is my emitter connection, okay? 1, 1.1, 1.2 in series, and this node needs to be ground. So the black wires here in my circuit are are ground, okay? Then we have again C3 from there to ground. The black one is ground, okay? The bigger pin goes to the higher voltage, so we have connected it to the emitter. Then we have emitter. Then we have collector connections. This is my collector, okay? Here, as you can see, we have RC going to, as I said, the red wire here, and C2 and RL to ground. Let's first check RC. RC is 2.2 kilo ohm, okay, and this is RC, okay. It goes to the red wire, which is positive 5 volts, okay. And I said that we have C2 and RL in series going to ground. Ground is the black wires, as I said, okay. They are connected, all connected together. The ground wires, which are black ones, are connected all together. So this is another connection. We are done with the, just make under because this is a frequent mistake that the students make. This is ground, okay. You don't need to make another wire here. This is ground. C3 is grounded, RL is grounded too, okay. So the series of C2 and RL is grounded, C3 is grounded too. Let's make the connections for base. First, the voltage divider. We have R1 and R2. R1 is 27, R2 is 15 K. So the base is here, okay, here. This is 27, this is 20K, this is 6.8 in series, this is 100 ohm, and this is 100 ohm. Will give me 27 kilo ohm. And it needs to go to VDC. It needs to, this is R1, it goes to red wire, okay. So here it's going to red wire. Then I have 15 kilo ohm, which is made up of 10 kilo ohm and two 10 kilo ohms in parallel. So 10 kilo ohm in series with two 10 kilo ohm in parallel, which is going to give us 15 kilo ohm. And the 15 kilo ohm, which is R2, goes to ground. And you can see that this is going to ground again the black wires. The only thing left is C1 and our signal and V in, and I need to show you the ground connection. I mean, not the ground connection, because you have a ground connection here too. Let's say that this is a rail, and this has V EE, and this has V CC. VCC is positive 5, VEE is negative 4. We don't have any grounds in this circuit. So I wanted to show you C1 and our signal connected to base. So here is the base connection, because the white wire is making the base connection. Then you have this capacitor, which is 1 milli in series with a 10K resistor. And you have the input of the function generator, which is the yellow wire. Here is the ground connection. I mean, all the ground connections. This was a ground connection. This black one here comes again, is a black connection. All are connected to this row, which is again, this one was a ground connection too, because of this too. Are all connected to the white wire here. You remember the red one provided the positive VDC, and the white one provides the negative VDC. It's going to be negative 4. Okay, and then from I need to have my oscilloscope or voltmeter connections to the negative of both channels go to the same row. Okay, the negative of both oscilloscope channels, the negative of the as you can see here, these two go to this line. So then you use the either this wire, the positive of the channel, or this wire to see the output voltages. As you don't need to measure IC, IE, and IB, and you just need to measure VE, VC, and VB, which are DC values. Waveform software. First, you need to make sure that the supplies are correct. Positive, as I said, negative needs to be negative 4. Then you need the multimeter or voltmeter. For this part, because we are just going to measure DC values, these settings applies, and I'm going to run the voltmeter. Now the positive of channel 1 is not connected to anywhere, so I'm going to connect it to let me show you emitter. So the orange one without the strip goes to the emitter, and I'm going to connect the blue one or the channel 2 to the collector. Okay, so as I said, the orange is going to the emitter and the blue is going to the collector, and you can see that it shows the values. And then you need to move one of these wires. For example, here I'm going to move the orange to the base, which was the white wire, but I'm not going to show you the values. You need to do it yourself. The next part of the question is asking you to do the AC analysis. First, you do the calculations and you find the overall gain as one of the parameters mentioned here. Then you, this is not the circuit that you're going to, this is a model for BJT and AC, AC equivalent of your circuit. The circuit is again figure 1. You don't need to change anything. The only thing that you need to do is to measure V out and see the gain from the output to the input. So you need to put a probe here and put a probe here. You know how much is the value of the input amplitude, so even you don't need the input measurement. So you just probe here to measure the V out, and then you can find V out to V in as the overall gain of the circuit. So this is not a circuit that you need to build. This is just a help for you to understand the AC equivalent of the circuit. So like before, you need the supplies to be connected 5, -4, and then you need the waveform generator. The question asks you to be the input to be 50 millivolt peak to peak, which means 25 millivolt peak, and 1 kilohertz sine wave. So 1 kilohertz, 25 millivolts. Sorry, 25 millivolts, and this is the input. Now we need an oscilloscope to see the output. We don't need channel 2, so we run the supplies, we run the waveform generator, and we run the oscilloscope. And then you press the signal and you do the necessary measurements. You must remember that you can either use this quick measurements or use the measurement here to add some measurements, including peak to peak and frequency and these things. So these are the things that you need for now. So you just measured find the total gain of the circuit, and then you need to answer the questions here.